In this tutorial, we will be discussing acid-base reactions and gas evolution reactions. Alright, so an acid-base reaction can be looked at similar to a double replacement reaction, where the inside ions come together and the outside ions come together. So the inside ions here are Na and Cl. The outside ions are H and OH to make water. So HOH, two hydrogens and an oxygen, H2O. So when acid base come together, they form water and some kind of salt. Now don't be fooled. Salt isn't necessarily HCl. It's just another word for an ionic compound. So it doesn't necessarily have to be HCl or NaCl. Alright, so these are also called neutralization reactions because of the fact that the water is produced. Because water is produced, water is neutral, and that's where they get that term from. Here are some very common acids and bases. You should have learned how to name these already. There's some other tutorials that we've made and that we've gone over that discusses how to name these. But for instance, hydrochloric acid is the acid that's in your stomach. Acetic acid is what vinegar is. So think of it as a double replacement reaction. SO4 with Ba, H with OH. So Ba and SO4. Ba is a +2, SO4 is a -2. Crisscross it and they cancel out. H with OH forms H2O. Make sure it's all balanced. There's 2 hydrogens here and then 2 more here. So that's a total of 4 hydrogens. So I'm going to put a 2 in front of the water so that way that makes 4. SO4, 1 and 1. Ba, 1 and 1. Oxygens, there's 2 here because of that 2 on the outside. There's now 2 here. So this is now a balanced reaction. Let's try another one. OH goes with H. Na goes with sulfate. So Na, SO4. Na is a +1 charge. SO4 is a -2 charge. Crisscross it becomes Na2SO4. And HOH, which becomes H2O. Now let's try balancing. We have 1 sodium here, we have 2 here. So I'm going to multiply NaOH by 2. Now I have 2 oxygens, and I only have 1 oxygen here. So I'm going to multiply this one by 2. Now let's look at hydrogens. I have 2 here, and I have 2 here for a total of 4. I have 2 times 2 for 4 here. The hydrogens I've taken care of, sulfates, 1 and 1. Often when you mix something with an acid, there are times that you'll get a gas that's given off. So this happens a lot of times with sulfides, carbonates or bicarbonates, sulfites, and ammonium. If you have a sulfide, for instance K2S, H2S is given off in the process because that hydrogen is combining with the sulfur. If you have something that's reacting with carbonates, CO2 is going to be given off. Something with a sulfite, SO2 is going to be given off. And ammonia is going to be given off, NH3. Just as an example here, we have HNO3 is reacting with sodium carbonate. The inside-outsides come together. So that's what you're used to seeing. The hydrogen is with the carbonate, and the sodium is with the nitrate. However, this H2CO3 then breaks down into water and carbon dioxide. So the final equation actually has that compound broken down instead. And so that's what's happening in the gas evolution and in acid-base reactions.